when you talk to the person who's selling you software and they say, hey, and you tell them, I need A, B, and C, and they say, hey, let me have you speak to one of my technical advisors who will really help you understand whether this product is a good fit for us. That's a sales engineer. That's what I was hired to do. That's what I did. And I was promoted to lead sales engineer. I ended up managing our sales engineering team for about a year. And now I'm our technical evangelist, having these kind of conversations with you. So first of all, I just want to say, I understand this is, Women Who Code group, so it's a privilege for me to be here, and so I really don't take for granted the way that you're listening to me right now as somebody who can get in front of you and who can contribute to your skills and to your learning. I don't take that for granted. Thanks for having me be a part of your journey, and let's kick it. Let's keep going. So. Let's talk about today's agenda. In the first part, we're going to talk about asynchronous processing, what it is and how to implement it in JavaScript. Then we're going to take a break, it'll be a 10-minute break in the middle. And then in the second portion of our program today, we'll talk about Kintone and how it relates to JavaScript and to promises. And and then work through some examples of using promises with REST API calls. Also, please note that somebody else is managing the slide deck, so there may be a few seconds delay as I'm just indicating to move to the next slide, and I appreciate your patience for that. So. Here's our core objective for part one for today. So these are your success criteria. If you walk out of here after part one with this clear for you, we've done our job and it's been worthwhile for you. Okay, so two pieces. One is going to be to understand what is a synchronous process, what is an asynchronous process, and then why promises are useful in those contexts. And so the first thing that we're going to talk about is what is asynchronous processing. Then we'll go into the pros and cons, and we'll talk about these two different solutions, callback functions and promises. So I sat with our team, and we were trying to think of a really great example to illustrate the difference between synchronous and asynchronous processing. This is the one that we came up with. I'm pretty proud of Genji and Will and Kelly who really put this together. Who, by the way, I didn't introduce them, but you'll notice that there are participants in our call today that have like Kintone next to their name. There's William, there's Genji, and Kelly at Kintone. So any one of those people, if you have a question or if there's any kinds of concerns that you have, you can go ahead and reach out to them. You can also post your questions to everybody in the chat, and Kelly or Will or Genji will assist you with getting them answered. So synchronous versus asynchronous processing. So I want you to imagine that you're going through a car wash, okay? And if you're stuck in the car, you're going to be going through this whole process of getting the car washed without the ability to do anything else. You're just hanging in there in the car, right? So if you want to do, for example, grocery shopping, you need to wait completely until the car wash is complete before you go grocery shopping. You've created like a dependency. But what if you could do both? What if you could drop your car off at the car wash and then go grocery shopping, do your thing, come back, and then either your car will have finished washing, or you'll wait for it to be done, but you'll have finished the grocery shopping. Then you can pick up and you're done. That, in a nutshell, illustrates the difference between synchronous and asynchronous processing at a high level. Let's go into some details. So, let's break it down. So, when you're in an automatic car wash, because you're stuck in the car, you don't have the opportunity to do multiple things at once. So you have to wait for, it's sort of like a queue, and you're waiting for tasks to complete one by one in a queue. Versus when you're in a different kind of car wash, a service car wash, You can go and take care of other business. You've basically got the ability to multitask. Now, how does this apply to code? Well, let's hit you with some code. In JavaScript, the code gets processed from top to bottom. So if you look over here, we've got 3 functions at the top of this little snippet. There's print word A, print word B, and print word C. And if you run this code as you expect, if you'll notice that we're executing print word A first, followed by print word B and print word C. And so synchronously, you'd get the result piece of cake, right? That's pretty straightforward, no surprises there. But the issue is if you're doing something on the internet and you've got some function in the middle over there that's taking a long time, it's going to bottleneck your other functions, right? So if, for example, we had that middle piece over there, print word B, you would slow things down completely until that little portion is finished. Well, what we can do asynchronously is we could continue to execute code until like we have to get a result from print word B, and then we can use print word B, the result over there, and then we can get everything that we need. So let's use an example, okay? If you've pulled the code, the sample code from the links that we sent you in the beginning, and we'll go ahead and make sure that those links are now available in the group chat. I'd like you to try this out, okay? And I'll go ahead and share my screen to show you exactly what that'll look like, so you can go ahead and follow along with me. So let me just have somebody kind of mark over here in the chat. Can you guys see my screen? I want to make sure that you can follow along with me over here.
Yep.
All right, terrific, thank you. So let's say we take this code over here. Hold on a second, here we go. There's a link that allow you to grab this code, and then we can go ahead and put it right in the console over here. And when we do, you'll see that this code was not executed in the order that we were expecting. Print word A, we're logging a word. Print word C, it's an identical function, and print word B, we're doing a timeout. Which is representative of something happening on the internet that's taking time. Okay, so you'll see we'll get the result piece cake of, and you might wonder, okay, well, how do we what do we do about that? I'll go ahead and give everybody 30 seconds to grab that link, try it on their own, and in the meantime, we'll set the share back up. Let me just quickly get a show of hands from the participants. You guys should be able to raise your hand. If you go to the participants button and you see a list of participants, you'll see it says raise hand. So please raise hand when you've completed that exercise. I can get a sense of where we are and how to pace the work. Okay, great, thank you. Got a few people raising their hands already. Okay, I'll give you guys another minute. Yes, thanks, Alina. What you can do is you'll open up your developer console, you'll copy and paste that code snippet, and then you'll hit enter. And to raise your hand, you'll see on the bottom of the Zoom bar, there's a button that says participants. You'll click on the participants button, and then you'll see like a little window pop up that says participants with a list of participants, and you should have a few options available to you, some buttons on the bottom of that window. One of them is going to be raise hand. Great, great, okay. For those of you who are still with us, I just want to make sure that everyone knows how to raise their hand. So could the rest of you guys please raise your hand at this time? Okay, thank you. All right, let's keep going. So as we saw, the result of that code was that we printed these words out of order. And again, this was to simulate that like something might happen in the normal course of like things taking time to execute over the internet. That means that excuse me, your JavaScript, even though you might read it from top to bottom, doesn't necessarily output results in the same sort of top to bottom way. So why is this useful? Well, imagine that you're getting information from Google Maps, okay? And when you're getting a lot of information from Google Maps, but if there was a certain queue, a certain order that had to be followed, where one thing had to wait for another thing, it would take a very long time for a sophisticated web application like Google Maps to load. If we can get important chunks of the Google Maps web application coming at us, and they come at us in whatever order they need to come at us, but there's no bottlenecks, that page is going to load a lot faster. And as just any typical web user, one of the most important qualities of your experience on the web is that things load fast. So this is really where the advantage of asynchronous processing is, and what it means for us writing JavaScript is that we need to be thoughtful of the order in which things execute, distinct from the order in which they appear as we're like reading our code. So this kind of benefit of using asynchronous processing comes with some caveats, some things that we need to be really thoughtful about. And one of the most important parts of that is the way that we manage the order of execution. So let's take this example, okay? Let's say we created a variable called money. Money equals 1,000. And we're going to create 3 functions, okay? We're going to say, we're going to minus some number from money in the function called minus a. And then it'll tell us if we've got more than 0, it'll tell us the amount, otherwise it'll tell us no money remaining, okay? Function minus b will do something very similar, but it will wait a second to execute. It'll wait a second to produce an outcome after it's been executed. And then in minus c, that function is identical to minus a. So if we run them in that order, minus a 600, minus b 500, minus c 200, let's see what happens. Okay, go ahead and grab that second code snippet, that part1 underscore asynchronous underscore processing2.js, and go ahead and run it in your console. once you're done doing that, please raise your hand. But actually, I'm going to ask that you all not put your hand down. You should be able to click the whatever it's called, unraise hand. Now go ahead and turn that off so I know who's actually going to be done with this exercise. So Victoria, Galena, Daisy, Fong, and Julia, please thank you so much, guys. All right, I'm going to go ahead and grab this screen, and you can watch me in the console as you're working. And again, if you've finished, you can go ahead and raise your hand. So what you should be seeing right now in this console is you've got these 3 different functions, and you've defined them, and then they're being executed one after the other: minus A 600, minus B 500, and minus C 200. And what you'll see over here is, as expected, minus A 600 will finish first. So you'll subtract $600 from 1,000, and you'll receive the notice in the console. You have $400 remaining. Minus B executes next, but it waits a certain amount of time before running the function inside of it. So what ends up happening is that even though it executed first, minus C will actually will actually interact with the variable money first, and produce produce its result that you have $200 remaining. After which process B finishes. And that's because of the nature of the asynchronous programming over here. Again, there's this difference between the order of execution and the order of interaction and output. So how do we solve this? How do we make sure that we are executing things in the right order, even though some of them can take unpredictable amounts of time? And how do we also make sure that we've got the freedom to have different chunks of our code run asynchronously when it serves us? So basically, how do we get the best of both worlds? So one solution is called callback functions, and the second solution is called promises. We'll talk about callback functions first. But what I will say about callback functions before we talk about them is just kind of like a historical reference, is that callback functions were the first tool that was invented to handle managing the execution order of your code. And we're going to show you a short video that'll give you a sense of how they work and how they guarantee the execution order. So Genji, could you go ahead and please play the video? And I can't hear the audio. So why don't I go ahead and I'll take the screen. We'll try it on my machine. If you cannot hear the audio, please let me know as soon as possible.
Can you replace that light bulb in the kitchen? What does it look like you're doing? Yeah.
So in that short video, what you saw was a character from Malcolm in the Middle, Hal, the dad, and he has got a problem, right? He goes and he gets home, he turns on the light bulb's not working. Okay, so he goes to find the light bulb, but the drawer where he's pulling the toolkit out the sound is making is off. So he goes to find his WD-40, but it turns out he's got no WD-40 left. So then he needs to go back into the garage and drive to pick up more WD-40, but it turns out there's an issue with the car. So then he takes out his car tools and in this way, there's a caricature of the way that callbacks work in all of their goodness and also insanity, right? You're guaranteeing that a certain stack of things is going to be done, but you can very quickly kind of, as one action hooks into another, things can get out of hand. So let's look at this from a JavaScript perspective, right? So with the result of one function, he's going to move to the next function. So I can't get more WD-40 until I fix the car, right? So I need to wait for that function to be done before then I proceed to the next step. Then I need, in order to lubricate the drawer, I need the WD-40. I can't proceed to the next step until I do that. So I've got this stack of dependencies over here that I've got to manage. So let's look at it from a coding perspective. Okay, I've got these normal functions, print phrase A and print phrase B. Okay, and if they were normal functions, they are separate, right? I execute the square in blue, and I'm going to see in my console 2 lines. Line 1 is going to say this is a, and line 2 is going to say normal function. But if I were to create them as callback functions, what I do is I use JavaScript's ability to pass in a function as a parameter so that I can guarantee that it's used at the right time. So let's take a step back about what I mean by that. So JavaScript, one of the cool features of JavaScript as a language is, this is going to be a technical term here, so you guys can, just feel free to file this away for use at a future cocktail party if you want. But JavaScript treats functions as first-class arguments, and what that means is that a function, just like a string, just like a number, just like an array or an object, can be passed in as a parameter into another function. So, okay, what does that mean? What that means is, if you take a look at this red square, that you can pass any function into print phrase A, and that function will execute at the time that it's been created, in the time that we made it to execute, and there will be a parameter passed into it, processing callback. So again, so when print phrase A executes, print phrase A will, in that last line on that red square, print phrase A will execute. It will pass the in as a parameter, the function called callback, which we've defined in the first 3 lines. And then as we're running print phrase A, we will execute callback at the appropriate place and time, where it says func processing callback. And processing callback will be the parameter passed into the function called callback. It's okay if you didn't get this right now. It takes a little while for this to sink in. Wherever you are is perfect. Let's keep going. We'll give you guys an opportunity to try this out. Okay. So go ahead and go to that console. Go to that list of code that you have, and pull out the snippet called part1_callback.js. Okay. And we'll go ahead and we'll run it in the console. Oh, and thank you, Alina. And as usual, once you've finished executing this code snippet, please raise your hand. Let's break down what we see over here. Okay, so we've rewritten some of these functions. Function -a is almost the same. Actually, sorry, it is the same. Function -c is also the same, and the difference is in function -b. Okay, in function -b, what we said is we can pass in a function as a parameter, and then it will execute in the appropriate place with other parameters passed into it that have been put there at that appropriate place as well. So what you'll see is we executed -a 600 and then -b 500 -c. So what that means is, -a executes, we've got 1,000, now we're down to 400, and then -b executes. And then because we've passed -c in as a parameter in callback style to the -b function, we've guaranteed that it will run in a certain place and time, that we've assigned. And so we've guaranteed that the -c function runs after -b. And you can see that over here in the slide that's in front of us right now. We've guaranteed the order of execution in the way that in the way that we wanted. So here's another way to look at callback functions. they're functions within other functions. So they run synchronously with the functions that they are called in. Again, we have the ability to pass in functions as parameters into other functions. This is a really big deal. That means that we can run other functions inside of functions at the time and place that we want. Like I got a function inside my function so that you can function when you wanted to function. And over here, we can see that this order is executing in the way that we were expecting. First, we do process A, then we move on to process B. Process C is hooked into process B, and we get the output that we wanted. So what's the core problem with callbacks? And the core problem with callbacks is the Malcolm in the middle problem. Okay, this is what we call affectionately callback hell. And so what callback hell is when you've got a process that has hooked into another process that is hooked in, sorry, a function, let me call it a function. A function that is hooked into another function, that is hooked into another function, that is hooked into another function. And we need to handle all of these different paths in the event that the function doesn't run the way that we want, or just in the way that we need to nest functions inside each other. Very much like what we saw with the Malcolm in the middle example. First, he wants to he wants to change the light bulb, but he gets stuck then like handling the drawer, but he doesn't have the WD-40, so he needs to go in the car. But the car isn't working, so then he needs to get the tools out. And that way, he's like stacked a whole bunch of different functions essentially that he's running in a stack, and he's got to handle them one at a time before they resolve. So the core issue with that is really from a maintenance and a syntax perspective, that is a pain to deal with and to debug. It's a lot of looking at text that isn't clear, and coding clarity, like the clarity of your written code is essential. You might not think that's the case in the first day that you write or the second day that you write, but you come back to your code a week later, 2 weeks later, 2 months later, 2 years later, and very likely you've got no idea what you did, or if you do, it's some passing memory, and you need to really be very thoughtful about relearning or remembering what you did. So having like a really easily available syntax to quickly and easily follow the logic of the code makes a really big difference in and just like the job of being a software engineer, which is where promises come in. So just kind of a historical note over here before we go into this example. Promises were not originally baked into the JavaScript language spec. They were added as what we call syntactic sugar, and what we really mean by that is some people made a library. They sort of made like an addendum to JavaScript that you could load with the work that you were doing, and it allowed you to use new functions that made it easier to code and clearer to code. And that approach and that specific terminology became so popular that it eventually got baked into the next version of the JavaScript spec when it was released. So now promises are fairly common in and around JavaScript in the wild. However, you still might find code out there that uses callbacks, and it's probably because that code that code is very old, and nothing's broken with it. So even though it might be a pain to maintain, you don't want to touch something that's working. And so you just need to be able to be, you need to be comfortable with callbacks. Or it might be that just like the person who coded wasn't familiar with promise syntax and coded in callbacks, which is okay too. But now what we hope that you're going to take away from today is some insight into how to begin to use promises so that you've got both options. So promises. let's take a look at how promises might work. So in the example that we're going to think of is grading an essay, right? So you submit an essay and then something happens over there that you don't quite have control over. And then eventually you're going to receive that essay. And then you've got options, right? So you've waited to receive this thing, and once you do, now you take some next actions. And depending on the result, you're going to take, either a success action or a failure action, right? If you fail the essay, then you'll rewrite the essay. If you succeed, then you will write a new essay. And that is the essence of how promises work. And in this metaphor, what I want to pull out that's going to be relevant for you is that you're doing something and sending it out there to some server for and then awaiting a response. And then depending on if that response, if you got a response that you were expecting, or if the response failed for some reason, you've got to handle both of those options. So let's look at what promises are, as officially defined. It's an object representing the eventual completion or failure of an asynchronous operation. And a promise object is passed on until the process is finished. When the process is finished, the success or error result is passed through the promise object. There's this notion of what are called pure functions. This is another thing that you can kind of put into your file away as cocktail party material. And a pure function is a function that if you pass in, or if you give it the same parameters, it'll always produce the same result. Okay, it's guaranteed. You put in blue and white, you get green. You put in blue and white, you get green. Or less abstractly, more concretely, you add 1 and 1, you get 2. You can add 1 and 1 1,000 times, and you'll always get 2. But when you deal with making asynchronous calls over the internet, in other words, you don't have the luxury of dealing with pure functions, because there is no guarantee that you will get the same result. If I make an asynchronous call to some server out there, and I pass the same result, and I pass the same data in, or I pass the same data out every time, maybe 30 out of 40 times I'll get the result that I'm expecting. And then maybe 10 out of those 40 times I'll get some kind of error because there was a server error, or there's some kind of issue in the transmission, or any one of a number of issues could have happened that had nothing to do with my code, but that don't guarantee that I'm going to get the same result that I was expecting. So promises work as an abstraction that allow me to kind of put that all in a box, and I'm going to interact with that box, like passing it in my code from one piece of my code to another piece of my code. And then at some point in time, I'll need to unpack the box. If it's a success, there'll be a certain pathway of logic. If it's a failure, it'll be another pathway of logic. But as much as possible, I've abstracted away the intricacies of dealing with the nature of my response. Let's go ahead to the next slide. And so we're going to use our familiar minus function, and we're going to turn it into a function with a promise. And the way that we do that is we're going to handle two conditions. One of them is going to be, well, first of all, let me back up a second. First of all, we're going to return a promise. So a promise is a particular kind of object, and a promise has two portions to it. It has a resolve portion and a reject portion. In other words, what should you do with if the response received was successful, and what should you do when the response received was a failure? Handle both of those conditions, and then return that in this promise object. So I mentioned that you take this promise object and you kind of handle it like a box, passing it to and fro in your code until you need to open it up and see what's inside. The way that you pass a promise to and fro from one part of your logic to another is by chaining with then syntax. So you'll see I've got this code, I've got this function called minus, and I am subtracting 100. I'm minusing 100. So what's going to happen is when that function executes, I'm going to return a promise. Now, if that promise is successful, then, and notice how I said the word then in English, which corresponds to the code. This is, by the way, like a hint, this is part of what makes it really easy to read compared to callbacks. Okay, so once I get the result of minus 100, whatever that is, then I'm going to do this next thing. I pass the result of minus, whatever that the outcome was of that whatever that result was, into the parameter of this new function. And I'm going to keep doing that until I'm done. So what that looks like over here is, and let's go ahead and next slide, please. Okay, I guess not the next slide. Let's walk through over here. Please go back. So if I start with 1,000, I'm going to minus 100. Okay, I'm going to pass in the result. So let's look. So let's look at this minus function. I'm going to return a new promise. I'm going to take 1,000. I'm going to subtract 100 from it. Is 900 greater than 0? Yes. Then we have a resolve condition. You have $900 remaining. Okay, that's going to be pushed into the parameter called result, which is at the end of the first blue arrow. And Geji, could you please move your mouse so that we're following along over here?
Oh shit.
Right. So we've calculated the outcome of minus 100. We've put that outcome in result. Then console log, we've got $900 remaining, and we return process successful. And we return it into the next then function. All right, thank you. Okay, and then we finish. So we pass process successful into the finish parameter because that's what's returned. We console log that, and then if there's an error, if there's something that happens that generates a failure condition, we're going to go into the catch. So here's what I want you to take away from this slide. Since if this is the first time that you're seeing promises, this can be quite dense. And Natalie, you asked a really great question. I'll get to that in a moment. What's important to note is that whatever a function returns gets passed on as a parameter in the next then function, unless you fail, in which case it skips all of the thens and drops into the catch. Natalie asked a question, why do you need the second then? And there might be cases where you have to guarantee that thing 1 happens before thing 2. Thing 2 happens before thing 3. And for that reason, you need two thens to guarantee that the third portion of your code executes after the second, and the second executes after the first. If that order doesn't execute asynchronously, then you can have it all be in one then keyword. Yeah, you'll notice that you notice that speaking about this in English can get really hairy. So I'll do my best to refer going forward to the then keyword as just that, and that'll be distinct from my use of the word then as in if then. Okay. Natalie and Arena asks, can you have more than 2? And the answer is yes. You can have as many then keywords chained after a promise as you'd like. Each one operates asynchronously. So what that means is, I'm sorry, it all is assuming that the code that you're running is asynchronous, so that the second then keyword awaits for the first then keyword to complete and pass its result into the parameter of the next then keyword. Again, kind of hairy in English. Let's give it a shot. Go ahead and let's take a look at this. So Arena, perfectly timed. And what you'll see over here is, I'm going to look at the left-hand side first, okay? We're going to subtract 600. Remember, the minus a function starts with subtracting the inputted number from 1,000, right? So then I'm going to get the result. I'm going to push that result in. I'm going to push that result, which is 400, into result A, and then I'll console log result A. Okay. Following that, I will execute minus B. Okay, and I'll push that result into the next then keyword. So if I've subtracted, I've got minus 100, so that's a failure. Okay, and then I will execute, and then so actually that's going to be caught in line 7. You'll see, I could, because if remember, I've got in this minus function, I've got if I can basically subtract this thing until I get above 0, I can keep going. But as soon as I get a negative number, it's a failure condition. And then if that failure condition happens, then I drop to this catch keyword. Now, on the left-hand side, this is a very convoluted way to do it. On the right-hand side, we've actually simplified it significantly. This is actually the same code being executed much more cleanly. You'll notice a few things are different. Okay, first of all, on the left-hand side, you see I have 3 catch statements at lines on the left-hand side on line 7, and on the left-hand side on line 10. On the left-hand side, Genji. Thank you. Left-hand side on lines 7, 10, and 13, I've got 3 different catch statements, each one of which matches up to the then keyword. But I actually don't need that. I need only 1 catch statement, because the way that errors get handled with promises is that the errors will bubble up to a single catch statement. So I only need 1, which you'll see on the right-hand side of the code, on the right-hand code, in line 9. Okay. You'll also notice that I am returning that while on the left-hand side of the code, I was executing functions inside of functions inside of functions on the left-hand side of the code on lines 3 and 5. And I also was chaining thens. As you can see, this got very hairy very quickly. What I can do instead on the right-hand side is I just need to make sure that anytime I'm using a then keyword, what I need to know about the then keyword is what I put in, what gets input as a parameter is the result of whatever came before it, and what gets outputted is whatever is returned. So I need to make sure every single then statement returns something, so long as I'm interested in passing it on to a new part of the chain. Does the right side code make it harder to find where your error happened? Let's go back 1 slide. Does the right side code make it harder to find where your error happened? Typically not, because what'll happen is your error will bubble up, and you'll have in your call stack the line where the error transpired. So you'll be able to go into your call stack and know like where in your code you're dealing with the issue. Great, that's a great question. So what we've been talking about so far is handling a chain of dependencies when you're expecting that like the first thing happens before the second thing happens before the third thing, and you've got this kind of nice, like there's one thing happening before another one thing happening before another one thing. But that's not always what you need. Sometimes, so one example I've encountered in my code is like I need to make multiple calls to multiple different APIs and wait until all of those answers come back before proceeding. That's different from what we've been talking about so far, right? And this is what you could imagine is happening in the Google Maps example, right? What you need is a whole bunch of data coming from various different places, and you've got certain kind of like checkpoints before you move on to the next block of code, but you don't need to wait until every single thing lines up every one thing lines up before you move on to the next one thing. So you need some way to have a whole bunch of promises go out at once, and also make sure that they all come back before proceeding to the next step. And that's what promise.all does. Promise.all, all is a keyword that you can use. That's a method attached to the promise object. And what it allows you to do is it takes in an array of promises, an array of, well, really they're functions. It takes in an array of functions, and it goes and like executes them, and then waits until they all resolve or reject before moving on to the next then keyword. That's what we're seeing here. Now, one of the important things to note is that if any one of those promises fail, then the entire promise.all method returns a failed result, and that's caught in the catch statement, which you see on line 5. So let's take a look over here. We've got this set timeout function that we were using before, and we're going to wrap it in a promise. And so to wrap it in a promise, we return a new promise. And if the money is greater than 0, then we resolve, else we reject, which is essentially saying we throw an error. Now what I'd like you to do is try this. You'll notice in the code snippets you've got available. You'll be able to copy and paste part1_promise. Please go ahead and do this. And what I hope you see as you're executing this code is that it is a lot simpler to follow than the callback code that we were using before. And thanks for the link, Kenji. As usual, please proceed to raise your hand after you've completed running this on your machine. Now what you're looking at over here, these are 3 functions, -a, -b, and -c. Very similar to how we've created them before, only this time we've wrapped them in promises. So actually these functions will take in a number and return a promise. And that makes our actual, like the logic portion of our code much simpler, as you can see. First, we're going to do -a. We pass the result of that along, and then we do the next thing, then we do the next thing, and then we catch any errors. Okay, I'll give another 30 seconds or so for the folks who are still copying and pasting the code, just to see that it's running. Really, the intention of you running this snippet is just like to poke around, to see that this code executes. I understand that it might not leave you with like deep insights about the way that this works, but again, we just want to kind of get our toes into the water and get used to how this syntax works and what we can expect to see as a result. And what you'll notice is that the results that we got very much are in line with what we would like to see. We want to subtract money up until we can't, and then we want to get something that handles the path when we can't do it anymore, which we've created as a fail condition. So succeed up until we can't, and then fail, and then that fail will bubble through the catch statement. And in this case, we will we'll get a message that says your cash total is negative. All right, let's go ahead and well, let's keep going. Okay, so before we take a short break, I want to summarize what we've covered so far. Okay, we talked about synchronous and asynchronous processing. We talked about how synchronous processing ensures that you're doing one thing at a time, and you're guaranteeing a certain execution order. And when you're processing asynchronously, that execution order is not guaranteed. What that allows you to do is to run things faster, but there are times when you need to guarantee that that code is executed according to a certain order. And so there are two solutions that the developers of the JavaScript language developed to solve that problem of guaranteeing execution order asynchronously. And the first one was callbacks, which has the benefit of well, it works, and it was the first thing to work, but it's hard to maintain and it's not as intuitive to review. And then later on, promises were developed separately and then incorporated into the language as a way to make it easier to read and easier to follow and to track errors, which is why pretty much everybody uses promises now in their code to the extent that their systems are capable of supporting it. So that's what we did. We went over what callbacks look like, how to run them, what promises look like, how to run them. And we're going to go ahead and take a short break for 10 minutes at this point. If you've got any questions, I will be happy to field them now. And the time is now 7:38. Please be back at 7:49. Take 11-minute break, and then we'll continue. For those of you who are still with us, where's everybody located?
You might have stepped away.
Okay, Annie's from Oakland. Annie, thank you for joining us. You guys can go ahead and unmute yourself. We'll just kind of take these next few minutes. If you don't have anything, it'd be a good time to start the recording up again. Perfect, thank you. Okay, folks, thanks for joining me. Part 2. Let's talk about applying our conversation about asynchronous programming to REST APIs. So the first thing that we're going to do is talk about like learning objectives. Okay, so if you're going to walk away from this section clear on how to use promises to call REST APIs with JavaScript, and you're clear on how to use Kintone as a framework for learning JavaScript, then you can check this. You can check this off. Job well done for everyone. We all pat ourselves on the back, and we go to sleep fulfilled tonight. So this is going to break down into the following agenda. First, we're going to talk about Kintone, and then we're going to talk about Kintone and JavaScript customization, how they go together, and then using promises with REST API calls. All right. So first things first. Kintone. What is Kintone? So Kintone is a platform that allows teams to collaborate and share their data through databases. So it's basically a very easy way to build a lightweight database and then work with people to share information and have conversations about that data without having it be in without having it hidden in spreadsheets or in emails or in various other databases. You've got everything in one place and in one time. So what's really neat about Kintone for our purposes today as developers and software engineers in training is that there is a wide applicability of JavaScript in Kintone. We have the ability to write and execute client-side JavaScript code. What I mean by client-side JavaScript code is when you run Kintone as a user in your browser, there is code that Kintone will execute on your machine that is pre-written, and it's not coming from the Kintone servers. It's living and executing on your machine. That's what we mean by client-side JavaScript. So with Kintone, you can, like I said, you can very easily build databases, and you do that with our drag and drop graphic user interface, our GUI. And so this is really excellent for software engineers and developers, especially if you're prototyping, because what you can do is you can build your database super quickly without needing to get into the weeds about like particular ways that you want to handle tables and like adding and dropping columns and stuff. It's all drag and droppable so that you can spend your quality coding time working on problems that are more significant and have more meaning to them. In business, what you can do with Kintone is you can collaborate with people to manage all sorts of things, like really whatever you want to build a lightweight database for, and then put like workflow management on top of it. So some classic examples are like expense reports. You've got this, you can imagine in like an app, what we call an app, you might imagine as a spreadsheet or a table in a database, and you've got records in there. So you might have records of expense reports, and as those records get passed from one person to another for approval, they go through a workflow. So people get notified at the right time, and then there's you can have reporting that's hooked into there that shows you like the status of your expense reports and whatever other information you need over there. Another example is interview management, as a prospect works their way through the interview process. Retail databases, tracking inventory, and then a typical CRM. So you can build all that stuff real simple with Kintone. And then you can customize it with JavaScript. So you can spin something up natively, and then you can add additional code to make it your own. Here's an example of what Kintone would look like with some additional JavaScript. So on the left-hand side in vanilla and native Kintone, you've got, remember I was talking about apps, right? Like you can imagine an app as a table in a database or a spreadsheet. So what you see in front of you is exactly what you'd expect to see in an app. This is a list of records, what we call, intuitively enough, our list view. And what you can do if you added some JavaScript customization to it is you'd be able to color various different fields in the list view based on, conditional parameters. So for example, if someone, in this particular case on the right-hand side, if someone's a great fit, maybe they'll be in green. If someone's not such a great fit, they'll be in yellow. Or actually, nope, let me correct myself over there. If the status of the role is vacant, it's in green, and if somebody is interviewing for the role, they're in yellow. Here's another example of what you can use JavaScript for in Kintone. So you'll notice on the left-hand side, you've gone ahead and you've saved a record, and on the right-hand side, you've created a pop-up box that appears based on the value of some text, and you can create a nice little way of making sure you in this case you want to save the record. Really, it's an open canvas for you. And so what you need to know about how Kintone interacts with JavaScript is, when you're running this code client side. Now, even though you're running it client side, you can make requests to some other servers out there. And then you can do that by making a REST API call. So that's a very useful thing that you can do with Kintone. And many of their methods and events support promises. So that's what's useful for us today, and also in general as you're coding on the Kintone platform. So let's talk about Kintone and JavaScript customization. Now, folks, if you have not already spun up a developer license, please do so at this time. It's free. And we do have like I believe it's free for a year. Will, is that correct?
That is correct.
So you can just like go ahead and play with your subdomain for an entire year, poke around, see how it can help you build some cool tools with it on your back end. So if you haven't already done that, please do that. If you have done that, please raise your hand so I get a sense of who's going to be following along with us in this portion of our work tonight. Great, thank you, Victoria. Thank you, Sorrel. Great, Daisy, thank you. Okay, I'm gonna go ahead and give everybody like 2 minutes. You can go ahead, kintone.com/developer-license. If you've got a QR code reader, you can go ahead and grab that QR code, and then just very quickly walk through that form over there. Irina says, I got 30-day Kintone trial. Okay, interesting. So
yeah, don't worry about that. If you got a free trial through that link above, it's just a process on our end. It says in the email that you'll get a 30-day free trial, and then on the back end, we'll change it to a developer license.
Thank you, Will. Yeah. Also, if you're concerned about getting any kind of sales calls, while we typically do that as like sales best practices, you won't have to worry about that. Our internal team is clear that that your registrations are coming in from this event, and that you're not prospects, unless you are a prospect, in which case let us know and we'll have that conversation separately from this one. But in any event, for those who are here for the promises and the REST API calls, fear not. Okay, I'm waiting for some more hands to be raised. So just please, as you complete this task of registering for the developer license, please raise your hand. Please also raise your hand if you are not planning to get a developer license, but you're planning on continuing with this presentation anyway. That way I can get a good bead on how quickly to proceed. And also please note that if you are not planning to get a developer license, some portions of this presentation will be difficult to follow. You can follow along with us, but you won't be able to replicate it on your end. Okay, great, thank you. Mandy, getting it, email verifications right now, awesome. All right, for the folks who haven't completed this step, could you just quickly put in the chat kind of where you are in the process? Again, so I've got a sense of where we are and how to pace the rest of our time together. Do we start the tutorial? Great, if you've already taken the license, please raise your hand in the participants window. So again, to do that, please, on the bottom of the Zoom, Zoom, you'll see invite participants, share, chat. You'll go ahead and click on participants, and then you'll see a window that'll show up with participants, and you'll have at the bottom of that window, there's a button that says raise hand. Please click on that to indicate that you're done. Manny's asking, do we start the tutorial? You don't have to start the tutorial at this time. What you can do is you can X out of that, and then you can always start the tutorial again in the future by clicking at the top. There's this black horizontal navigation bar, and there's like a graduation cap that should be brightly colored, and that's how you would start the tutorial again in the future. Mandy, great question. Thank you for asking. All right, I'm going to wait another minute or so. And again, if you've completed this task, either you've done with the Kintone Developer, you've gotten your Kintone Developer license, or you're not planning on getting your Kintone Developer license, please raise your hand. If you have not raised your hand, I'm assuming that you are with us and you're paying attention and you're just in the process of getting it done. And if you're kind of sort of here with us, you've got another 45 seconds and I'll assume that you're still with us. That's the blessing and the curse of being, thinking like a software engineer, is noticing where my logic paths are failing and where my assumptions might not be borne out in reality. All right, we're going to go ahead and get started. So please, let's move to the next slide. Oops. Okay, so what you'll do is you'll access your subdomain and you'll log in. You'll have your username and your password. And once you've passed through that familiar screen, you'll be presented with a page that, hold on one second. you'll be presented with a page that has a portal at the top. And I will go ahead and show you what that looks like momentarily. I'll say portal at the top left. And what you're going to do is you'll see there's this area over here called apps. And this is where you're going to create a new app. In fact, there's a little message over here that indicates that's where you're going to go. Remember, an app is like a table in a database or a spreadsheet. Okay, and over here you've got various different ways to create apps. You can create them from scratch. You can do importing from Excel or CSV. What we're going to do over here is we're going to look for a particular example. Now, Genji, if I'm not mistaken, that's the onboarding example. Is that correct? Employee onboarding? Hey, Genji, just let me get a confirmation over here.
And you got a yes on the chat.
Oh, thank
Yes.
you.
Sorry.
Oh, perfect. Okay, great. We're gonna go ahead and add this app just like that. Okay, and now we'll see it over here on the right-hand side of the page. Employee onboarding, app added. Okay, we click on this app, and remember, it's like a table in a database or a spreadsheet. So what we're going to expect to see is a list of records, and that's in fact what we do. What we see over here, we've got like sample records. Okay, I'm going to go over here and turn the screen over to you, Genji, so we can continue with the deck. And so what you'll see over here is a few core navigation points. Okay, your data is located front and center. On the left-hand side, there are these blue kind of thumbnails of pages. This is where we can access the details of each record. We'll access the setting by clicking on the gear wheel at the right-hand side of the screen with the white background. And then we'll add new records. We'll add new data by clicking on that plus sign. Okay, so what I'd like you to do is I'd like you to click on that gear wheel, the one that says app settings, the one with the white background right next to the, with the white background on the right-hand side. And you'll come to a page that has a few tabs on it, okay? Front and center is our form tab. This is our drag and drop app builder. This is where we'll be able to pull fields from left to right, but that's not what we need right now. What we need is we need to go into the app settings and start playing with the JavaScript. And to do that, you'll see there are 4 tabs. There's form, views, graphs, and app settings. Click on app settings, okay? And once you do, you'll see there's 3 columns. And in the second column, second item down, second clickable item down is JavaScript and CSS customization, okay? We'll click on that, and then what we're going to do is we're going to add the file. What file are we going to add? part2_alert. So what you'll do is you're going to grab that snippet from part2_alert, okay? You'll save it in your local text editor. And then what you'll do is you're going to go ahead and add that file and upload it and click save. Why don't we take a few minutes now to do just that. And Genji, could you please put up the gist? Actually, instead of Genji, what you can, Will, would you kindly do that?
Sir, were you asking me to do that?
Yes, please. I don't want to have Genji lose the page.
Oh, Genji's already posted it. So.
Okay, great. Thanks, Genji. On the ball as usual, my friend. And what you'll do is you'll save it as like alert.js or alert, so the title part2_alert.js. Remember to save it as a JS file. So once you've added that file, and then you've hit the blue save button on the left-hand side, okay, you'll be taken to the app settings page, and you'll need to click the update app button in blue on the top right corner of the screen. Doing that will basically take the changes that you made that were waiting and staging and push them to production. That's a pretty useful way to think about it. And as soon as you do that, you'll notice that we're immediately presented with an alert. It says, hello, Kintone. So what we've done is we've gone to the same page that you've seen just a few moments ago, and we've customized it with JavaScript so that an alert will pop up. This is really just to show you that you can use JavaScript over here in Kintone, and there's a lot of things that are possible. Almost anything is possible over here. Okay. So what I'd like to do next is talk about promises and REST API calls. So let me just get a quick show of hands. How many of you are familiar with a REST API? Just go ahead, let me get a quick show of hands. Please raise your hand. Yes, I know what a REST API is. I've heard it before. I've heard of it before. Okay, great. So a really useful metaphor for thinking about a REST API is a restaurant. Okay, so I want you to imagine that you are at, there's this restaurant I go to right by our Kintone office in San Francisco, and it's a great Vietnamese banh mi restaurant. It's called Banh Mi, and I go there for lunch. They've got under normal circumstances, I go there for lunch, and they've got this great happy hour special on sandwiches between 3 p.m. and 6 p.m. And I sit down at the table, and I've got a server who comes over to me, and I make a request. Okay, I say I want my my typical my happy hour banh mi special, my sloppy Joe banh mi with no jalapenos, and the waiter says, okay, great. They take my order, they go away, they take care of some business that I don't quite have visibility into. Only the next thing I know, I get something back. The waiter comes back later, and they give me what I was looking for. In this particular example, let's just say I ordered a cheesecake, and I received a cheesecake. Okay, and so this is actually a really illustrative and fairly accurate metaphor for what's going on when I'm making a REST API call. I've got a menu, which is like I've got some documentation that tells me how to make a call, and then as a client computer, I am making a request out, following these instructions to this REST API. Well, it's not like using the REST API formula to reach a server. The server does a bunch of stuff that I don't have any visibility into, and then it returns a response that gives me the resource that I was looking for. Now, let's take a concrete example. Let's take Instagram, for example. So I go ahead, I type www.instagram.com into my browser, and I am making a particular kind of request to the Instagram server. And that request is like, show me this page, give me this user's Instagram posts. And then they're going to return what I asked for. Here are the user's Instagram posts, just like that. So here's the thing you need to think about when you make a REST API call, right? You're not just, there's a formula to make this call that works. If you don't follow the formula, your call probably won't work. You probably won't get the resource that you were expecting, and you'll experience some kind of failure. Now I can show you in code what that REST API call would look like, but I think it's better to think about it and reason about it first, so that once we see it in the code, it'll make sense a lot easier. And so think about it, right? If I'm going to make a call out to some server out there, if I'm knocking on someone's door and I'm expecting them to answer and give me what I want, I need a few parts of my request to be there. So first is, I need to make sure that I'm calling the right place, right? In the restaurant example, I'm mixing metaphors a little bit, so let's forget about knocking doors. Let's stick with restaurants. In the restaurant example, who am I calling? I'm calling the waiter. I'm calling the server. This is the person who's expected to interact with me. I'm not calling a fellow patron. I'm not calling a waiter somewhere in some other restaurant. I'm not calling a taxi cab. I'm calling exactly the person who's expected to assist me. I am telling them what I want them to do. In this case, like, bring me a cake. I'm giving them my permission, right? So like, under whose authority am I to ask for this resource? Well, I'm a paying customer. And then I need to tell them the details of my request. Well, what kind of cake do I want? I want a cheesecake. And then I will also want to, tell them, once what should I do after I receive that information? It says what to do after being severed, but I want you to imagine that it says served and that there's nothing being severed over here. Let's go to the next, and actually before we go to the next slide, let's go back a moment. So what you'll see is we've got this method called Kintone.proxy, okay? And it's gonna have all of those different components to it, right? So when we see this Kintone.proxy code shortly, just want you to know, this is all the things that we need. This is the address that we're going to. This is the particular thing that we want them to do. This is the permissions and any other miscellaneous information we need to pass on to make sure that we get what we want. This is the data that we're asking for, and then some kind of a callback. What are we going to do with this information once we've received it? So please stay on the lookout for that Kintone proxy call. Okay, so what does this have to do with promises? Well, remember, promises have to do with asynchronous code, and when we're using REST APIs, what we're doing is we're making some kind of request out there to the internet, not knowing how long it's going to take us to get that response. Typically it might take a few milliseconds, 100 milliseconds, but it could take as long as a minute. You could time out. We could never receive a response. So that's where promises come in handy. Now, one of the things I want you to be aware of is that clients, when we're making REST API calls, there's certain kinds of good practices that pretty much the entire internet has aligned on. Like the people who have built the internet have aligned on to make sure that, let's just say, everybody is playing nicely and according to the rules. And one of those rules is what we call cross-origin resource sharing, or CORS. So here's the issue with CORS, okay? typically when we are making, if I'm on google.com and I make a request, I'm making a request to google.com because that's where I am. If I need to make a request from some other website that's not google.com, I need to do it through google.com. I need to have the server handle all of my communication with any other server. So in other words, when I am on a web page, when I'm on a domain, on a URL, as a client, I am typically only allowed to interact with the server whose page I am on. Now, on the client side, this can get a little hairy. Let me show you why. Okay, I want you to imagine that here I am in the restaurant and I've skipped asking, I've skipped the rules. I am trying to go directly to, actually it's somebody else's kitchen, right? So there I am sitting in my, I guess it's the Cheesecake Factory, and I decide I want to now talk to the cook, the line cook at my Vietnamese restaurant. That's not gonna fly. So what we need to do to avoid these errors, because what will happen is if we try to do that, we'll get an error, is we need to call the REST APIs through Kintone. That's why we have this Kintone proxy method. So instead of in our code saying, okay, here I am, I'm on the Kintone web application, I've built a lightweight database, I need some information from some other web service out there. I'm just going to make that call directly from the client-side code that I'm executing on my computer. What'll happen if I try to do that is I'll run into an error. It'll say, you know, basically, you're not allowed to do that. You are here on Kintone.com. You are trying to get information from Google.com. No pass. So Kintone has this method called proxy, and what that allows us to do is we talk to Kintone. We talk to the Kintone server. We say, hey, you. This is the REST API call we want to make. Please make it on our behalf. Please facilitate it, get a response, and then give it to us here on the client side. And that's what this proxy method is doing. And so that's how we're going to avoid running into any CORS errors, any cross-origin resource sharing errors. So cross-origin meaning like here I am at Kintone.com. I want to now cross origins to go to Google.com. I want to share resources from over there. That's an error. That's a no pass. That's how I avoid running into cross-origin resource sharing errors. Okay. So let's take an actual example. Okay. We've got this API called Currency API, and they've got cross-origin resource sharing disabled, meaning that if we run this code from the client side, if we're on Kintone.com and we make an API request to currencyapi.net from the client side, we're going to get an error. Okay. And so this code over here is going to fail. It's going to give us the kind of errors that we saw 3 slides ago. It's going to basically say something like, you're not allowed to do that. So what I'd like to do going forward is I want to use the Star Wars API so that we can play we can play with our REST APIs with this tool. The Star Wars API is the world's first quantified and programmatically formatted set of Star Wars data. Let's take a look at how we can proceed. What we're going to do is in Kintone, we're going to create a button on the Kintone app. When that button is clicked, we're going to make a REST API call to the Star Wars API. We're going to wait for the response, and we're going to display the result in the console. Let's rock and roll. Okay, so the first thing that we're going to do is you're going to go ahead and grab the code snippet over here, part2_call_swappy.js. And what you'll notice, and what you're going to do is you're going to grab this code snippet, You're going to save it, and you're going to upload it to Kintone, just like we did before with that alert. Okay, so Genji, why don't you go ahead and share your Kintone example app? And thanks for showing it. Now you'll notice there's a button over here that says click me. This is a new button that Genji just created by uploading that, that code snippet. Go ahead and click on that button, click me. And what you'll see is we've got a whole bunch of things that just appeared in the console. We've got start search, then we've got like we've retrieved the this information about Luke Skywalker, and then we've got in the console it's telling us end search. So let's see if you can go ahead and replicate that that behavior. Go ahead and take 2 minutes. So what we did actually, and let's go back for a second. What we did to make this work is this code allows us to, when we click on that, first of all, show that button when we're on the right page. Sorry, when we are on the right page, which is that list page, then we're going to create a button. It's going to be located in that particular place. When someone clicks on that button, it's going to make that REST API call using Kintone.proxy, and then there's that then keyword. Go ahead and console log and search. And so this is how you walk through again, and you're going to go ahead and add that file. And Genji, can you take your chat out of the way, please? Thank you. And you should go ahead and you should see this console output just like we were showing you before. Now here's what you'll notice, okay? If we wanted more information about, say, Luke Skywalker's homeworld or the species that Luke Skywalker is, you'll notice that there are other endpoints that are referred to. We want to grab that information. So let's see how we can make chain API calls to get all of that information. Okay, so this is where the second snippet's going to come from. And what we're going to do, first of all, is, again, when we are, when we're on the right page, we're going to click on this, click on that button. That button is going to create an API call, and it's going to get the Star Wars character with promise. Okay, so let's follow that from number 1 to number 2. So the next thing it's going to do is it's going to return a promise. Okay, and that promise is going to say, hey, go to this Star Wars API URL. I want you to get this information, and then I want you to return it. And then get once we've returned that that information. Sorry, once we've returned that response, we're going to grab an important piece of data from that response and use it to make another API call, right? Which is exactly what we were just looking at, right? We got this response back, it had a URL in it. Now we want to automatically use that URL to make another API call. This is exactly what we're seeing over here. And then once we've that information, then go ahead and output that. So let's go ahead and take that part2 underscore call underscore swappy.js and add the file, and let's see how it's going to work. Oh, Genji, you can, never mind. So now when we click this click me button, okay, we've started the search, and look at what we've come back with. We made our first API call. We used the information from that first API call, in other words, that home world and those species URLs, to then make new API calls following the promise chain that we created. And then we're gonna, and then we console log and search. You guys will have access to this deck later, and you can always go through these slides to walk through, what you should expect to see and how it works. Okay, so what have we done so far? Well, we talked about asynchronous and synchronous promises. We talked about using callbacks and promises, and we encouraged you to begin using promises because they make the code cleaner and easier to read. And then we began applying that to REST APIs. So we talked about what is a REST API, how do you call it from the client side, and how do you use Kintone, and how do you use Kintone methods to call those REST APIs in chains of promises. So I just want to thank everybody for your time. At this point, we'll take any questions. Again, you've got access to this, to these code snippets and to this deck. So, my intention was that you come away with some clarity on what promises are, how they fit into the kind of the more higher level picture of what you want to do with JavaScript, and how you can use Kintone to help build the stuff that excites you. Thank you for your attention and your participation. And at this point in time, I will open the floor. You can go ahead and unmute yourself, or if you're shy, we'll also take questions over chat. Thank you. Thanks. Thank you so much for this session. Great job. Awesome examples and nice slides. Great. You're welcome. It's my pleasure. Thanks for being here. Mandy, very shy. Totally understandable. Nice presentation. Thank you very much. I also want to thank my colleagues who have just been right behind me, making sure that we're working together, giving you guys what you need. Will and Genji, hailing all the way from Japan. Genji, thank you for managing all of the aspects of this. Kelly, thank you for taking care of all of the back end aspects, answering questions. I want to thank Alina for just getting you all together, providing us with this platform to share this information with you, and for your upbeat energy and your appropriately timed posts. And it looks like we don't have any questions coming in, so I'm going to go ahead and turn the floor over to Kelly. Is it you that I'm going to be turning the floor over to, or Genji?
Or Genji, I think.
Genji.
Hello. Yes, I just wanted to say thank you so much for everyone participating in this virtual meetup. And thank you for overcoming the technical difficulties with me. I wanted to introduce, we wanted your feedback, so please fill out this quick survey to have a chance to win a $25 Amazon gift card. Yes, the link will be posted. Sorry, can someone post the link on the chat as well? Thank you very much.
Oh, no, it's coming faster than I can. Thank you, Kelly.
Yeah. The content, several people have been posting the short link. It will be here, and our code is in a zip file, presentation in a PDF copy. I just wanted to share since several people were like participated midway through. So all of our content will be here. All right. If anyone have any questions, I think that would be it.
Yeah, just wanted to point out, some people asked for sharing the recording of this the Zoom meetup. I did record it. I'm just going to check with Alina if it's okay to share it with everyone here.
Yeah, sounds good.
Okay, then we will find some way of hosting it, and we'll either pass it on to Alina or post it in the comment section of the meetup.
Will, do you think it might be possible to add it to that list of resources that Genji shared?
Yes, we will do that. We'll post that video on the page with the slide and the code as well.
All right, great. And C is asking, is 5 a good or bad in rating? I believe 5 is, on a scale of 5 is the best. 1 is the worst.
Yes.
I wish you and your family and your loved ones well in this time. Please stay safe, be healthy, and code up.
Have a good night, everyone. Thank you for coming.
Good night. Good to see everybody.
Bye.
Yeah, I think there's a lot of content in this presentation. So if you still have any questions, later on, you can either post them into the meetup chat or the meetup messages, or you can poke me on Twitter if you want, or you can poke Nim on Twitter, I hope.
You could do that. You should find me on LinkedIn. Nimrod Grinvald is the best place to reach me at.
Also,
Amazon gift card in yen. I hope it's in dollars, and I hope it's it.
yes.
Yes.
It will be in dollars. $25 USD. Also, if you have any questions about Kintone, we have a Kintone Developer Program community where